Good afternoon, everyone. Happy Thursday, and welcome to this week's episode of the M Word. My name's Robin. I'm the Technical Director of Man & Machine in the UK. And as always, it's a pleasure to have you here with me this afternoon. So for those of you that are new to these sessions, we try and air these every Thursday at 2 p.m. just to give you a tip or a trick or a workflow or something that will hopefully improve your productivity or day-to-day inside of an Autodesk piece of software, whether it's Revit or AutoCAD or Inventor or VRED or Max. We try and cover different aspects that might help some of you people out there. So if you are new, welcome and thanks for joining us. As always, keep an eye on our social channels, whether it's Facebook, LinkedIn, YouTube, of course. We regularly put new content up and have these sessions alongside a whole raft of other social media content, whether it's a video or webinar, live Q&As, so on and so forth. Keep track of us and please like, follow and subscribe to see the latest content as soon as it comes up. So this week, what I thought that we'd do is have a bit of a change. Past few weeks, we've focused quite a lot on the construction industry. We've looked at Revit. We've looked at Twinmotion last week. What an awesome application that is. And this week I thought we'd go back to product design and manufacturing. So we're going to use Inventor today to look at some sheet metal workflows. So I guess my manufacturing head feels a little bit left out, but like a good old Labrador, it never disappears and it's always there to put a smile on my face. So we're going to take a look at Inventor and I'm going to try and go through this as a bit of a step-by-step tutorial almost to try and get you started, get you using the application and the sheet metal functionality inside of Inventor, because if you are cutting flat patterns and bending up metal, it can be hugely beneficial to your workflows. So without any further ado, let's make myself shrink into the corner. There we go. And let's share my screen and hope that it shares the right screen, which it doesn't. That's annoying. Let's change that setting. It did this last week. I'm so bad at this. Why can't I get this right? It fails every time. Failure. Right, okay, 2 seconds. Let's just actually choose the right monitor, which is monitor 0, not monitor 1. There we go. And yep, I'm small. Brilliant, great, fantastic. Apologies, every week. There's got to be at least one mistake. It wouldn't be a live session if there wasn't one mistake, right? That's what I'm going with anyway. So I'm an Inventor. This is 2023. These workflows, arguably speaking, you could use these back to real legacy versions of Inventor if you wanted to, for the most part, because the core functionality is there and has been there. There's been a vast array of improvements over the years in the sheet metal functionality, but again, it doesn't matter if you're on 23, 20, 19, 18, or even earlier. These workflows should work for you in exactly the same way. So inside of Inventor, I want to create a sheet metal part. So when I say that I want to create a new file from either of these two dialog boxes, I have a specific template that I will need to use for sheet metal components. And it's up here, sheet metal. Dependent on your template configuration, you might have sheet metal open brackets millimeters or open brackets inches, depending on where you are in the world right now. But in my case, I'm just going to choose sheet metal. The reason you have a separate template is because there's some specific defaults that Inventor needs to set when you are working with a sheet metal part. And we're going to talk through these in a second and go through them in a bit of detail so that you appreciate what it's doing and why it's doing it. Because when you're developing a standard part, let's say you're modeling up this mouse, you don't necessarily have any uniform thicknesses or anything like that you need to adhere to. Whereas in sheet metal, you're going to be working with a sheet of metal that has a set thickness, and you're going to need to work with certain bend radiuses or K-factors that you're just going to need to understand. By using a sheet metal part template, it has those options in there that you are able to change. So we'll select that sheet metal template, we'll hit create, we'll wait for Inventor to do its thing, and open up that component for us. And generally speaking, if you're brand new to this, the first thing that you're going to want to do is just head over to your sheet metal defaults and take a look at what's going on. So on your ribbon bar, if you just head over towards the right-hand side, you've got this setup tab. And at the top there, you see that I've got a sheet metal defaults. Now, if you're following this along as part of a pick and click, let's say, or a self-paced tutorial, if you don't see that, it's probably because you've started a standard part rather than a sheet metal part. So if you don't see flanges, faces, cuts and corner seams, you're not in the sheet metal part. But don't fear. If you've accidentally gone into a standard part component, like he says, waiting patiently for Inventor, like this one, and you see extrusions or revolve, you've got a big convert button on the right-hand side. You can use that, it's what it's there for. I don't like using it myself. I prefer to start from a sheet metal template reel, but you can convert using that button if you want to. However, if we go into our sheet metal template, we can say, go into my sheet metal defaults. These are just the complete off-the-shelf defaults that come with Inventor, and they're pretty much the same as they have been for a number of years using the Inventor application. If you're using this in anger day to day, then you're going to want to change this actual template and save it back as the template so that these sheet metal standards are then the same across all of your designs. But generally speaking, we have this sheet metal defaults. And what this allows me to do is define certain standards of working inside of the sheet metal interface. So if we go into this sheet metal rules at the top and click edit sheet metal rules with the little pencil, you can see that we've got a whole variety of different options with regards to how Inventor is going to treat the different tools and functions and aspects of what we're doing. So under here, we've got the ability to change options with regards to the sheet, so the actual sheet metal material that you're going to use, how it's going to treat bends, and how it's going to treat every corner as well. So what we're going to do is just show you through some of these and just explain how some of them work. So under the sheet tab here, you can see at the top that we've got a material. It's just using the standard generic physical material inside of Inventor. If you are always defaulting to galvanized steel or stainless steel or aluminium or whatever it might be, you can go in and choose within your standards what the default material is. Yes, you can still change it with the material property drop downs at the top of the screen, but we can change the default. That's obviously important with sheet metal because different material bends in different ways. So the likelihood in reality is you're going to have several sheet metal rules for each physical type of material or thickness of material that you use in real life, because each one of those is maybe going to bend slightly differently or have slightly different reliefs and stuff like that. For the purpose of this, I'm going to leave this on generic. I don't need to change it, but it's important that you understand that generally you'll set up several different defaults for the different materials you use. So if you have steel and galvanized steel, you'll have one setup for each of those within your sheet metal template. What we can also do is specify the thickness. For the purpose of this, I'm just going to manually up this thickness and say that we're working with 1 mil material rather than half a mil material. But again, you would configure this to be the same as what you're working with in reality, so the physical material that you've got on the shop floor. We can choose how to treat things like rips in material, how to treat things like miters or seams. I just want to use the same thickness as the material, because generally speaking, that's what most of you will be doing. But we can change this. We could say that it's thickness plus half a mil. We can say that we override it to a 2 mil default, whatever it might be. We tell Inventor those defaults that we want. We can do the same with regards to K-factors. So you can type in the K-factors that your guys on the shop floor need to actually bend and work with this material in reality. And we can choose to work with those unfold methods either with a linear K-factor, with a custom equation if you need to, or indeed with a bend table. So we can customize this and configure it to suit your shop floor or your manufacturing and fabrication requirements. If we go back to our default millimeters, we've also got bend angles. So is it going to use angle A when it's reporting on your bend, or is it going to use angle B? And we can change this again, dependent on whether you want to use the open angle or the bending angle. Completely customizable, it's up to you. We can do the same thing for bends. So what relief shape do you want on the bends? Do you want to have a straight or a tear? In my case today, I'm going to use a tear, so it's got no physical relief size. Maybe a round, you've got a physical rounded relief or a squared relief against that flange there. So for the purpose of this, let's say today that I'm going to use a tear. And again, I can choose the sizes that are relating to that relief. The same thing on a corner, we can choose how it treats every corner. So do we want to trim to bend? Do we want to have a rounded shape? Do we want to have, again, another tear? It really depends what bending machines or manual bending processes or whatever you have happening on the shop floor. You mimic Inventor to work in the exact same way. And again, if you have any questions or feedback that you want to give us or ask for help on this, just reach out, drop us a mail, send us a message, leave us a comment, just get in touch and we can give you some advice and help you. Again, for the purpose of this, I'm just going to leave this on no round horrendous. Let's have it on trim to bend, which is by default, just so you can see something happening there. If I save my defaults here and then go back to my sheet metal defaults, this is where you would then specify. So just go back a few steps. I said that in reality, you're typically going to have a situation where you've got a rule per material or thickness of material that you're using, or maybe for different K-factors to use on a different machine. So you'll have a sheet metal rule listed in here per one of those. So when you start your sheet metal part, you would come into your defaults and you would choose the one that you're wanting to use. Okay? You've then got the ability to override, should you want to, materials and unfold rules as necessary. I'm going to leave all mine as default and I'm done. I'm ready to now design sheet metal componentry. So there's some important and some vital first steps, and these defaults underpin everything. Now, one thing to note, I'm just working solely on my laptop. These defaults are stored onto my laptop unless I tell Inventor otherwise. So go to your tools, go to your application options. Under the Files tab, you'll have design data. and you'll be able to see where that design data resides on your machine. If I browse to my C drive, users, oops, helps if I spell correctly, users, there we go, and public, goodness me, public, there we go. If we come into our public documents within File Explorer, public documents, go into Autodesk, go into Inventor, you'll have a design data folder. Now that could be overridden by your project, so remember to check your IPJ as well. But if you come into design data, you can see all of the specific design related information with regards to Inventor. And you can see that I have my bend tables in there if I'm using them from a sheet metal perspective. And if I look down the bottom, we've got our unfold rules, our sheet metal rules, and we could either copy these from machine to machine, or the likelihood is you have a centralized design data that you can use and share across your team. When it comes to creating parts, the process is not dissimilar to what you have when you create a standard part. We typically start with a sketch, and then we do things with that sketch to turn it into some 3D, so we use a feature. But we don't typically have things like extrusions and revolves, because we're not really dealing with a form like that using sheet metal. We model the component in its folded state, and then we unfold it to make the flats. So let's just jump in and just do a really simple couple of things to show you how some of the tools work, and then maybe we'll fold up a simple component, do a drawing, and show you some of the outputs that you can get. So from here, I'm going to show you that we've got tools like face instead of extrude, and flange to create bends. So let's just show you how a couple of these work initially, just with some quick fire tutorials, and then we'll just model something up. So let's go to Start Sketch, and much like with Inventor, we just choose a flat face to work from. So let's come and choose our floor plane, our top plane here, and look at this from the top down. And then from there, what I want to do is specify a face. So let's imagine I'm going to make a sheet metal box that's got a single face with flanges all the way around the outside and maybe a couple of hems. So if I come in and say that I want to create a 2-point center rectangle and create, like you would normally, a rectangle that either is or isn't constrained, how you see fit. So for the purpose of this, let's say that I want to create, I don't know, a 300 by 225 mil flat surface on the bottom of my part, and I'm going to finish that sketch. Rather than use extrude, which is what you would use in reality, we tell Inventor to create a face using our sheet metal defaults relating to the sketch that we've placed down. Much like your usual Inventor functionality, it will identify any closed loop that you have and it will select it for you. It highlights that and it allows me to change any defaults that you might want to, but I wouldn't. I implore you to use the defaults. That's why those sheet metal defaults are there. So I can just leave all of this as default and hit OK, and I end up with a sheet of material. If we want to go around and place some flanges around the outside, we just choose flange, and then with each of those we come in and select each of the edges that we want to create flanges from, which is basically a bend. So we go and tell it to create these flanges, so bend the metal and extrude the metal up. I guess you could use that terminology. And then for each one of those, we define some options. Yes, you've got the ability to select all those loops as one, so I was not lazy, which is unlike me, and selected all of them individually. I could choose all of them as like a loop if I wanted to. But then each one of those, I can select it and choose how to work with regards to its width. So let's say this one here, I don't want it to be exactly the same length as the width of the edge. I want it to be a set width, which is going to be offset to this face here by 50 mil. And then I want the width from that point to be 200. No, not 200. 190. There we go. Press OK. This one, I can have, again, some similar overrides too, should I want to. So each one of those flanges I can individually customize. And I can do the same thing with the corner. So we've got some defaults, but it might be that I need some specific corner detail in there on that particular bend in order to get this manufactured. I can add that as I see fit. From there, I can choose the angle. So I can say that I want these flanges to be 45 degrees. I can say that I want them to be 10 degrees. I can say that I want them to be a right angle, which is, in this case, what I want to do. And then I can come up by a distance, much like you would with an extrude. You have other options like go to another face. But let's just come to a distance and let's just say that we want to go up by 100 millimeters. We can position the bend inside, outside, aligned, so on and so forth. Just press OK, and this will go ahead and it will create your sheet metal component. So already now we have a face and all of these bends. Let's just add a couple of hems on there just to show you how that functionality works. So let's choose hem to roll a hem around the top of one of these edges, which will basically roll the material over on itself. Let's choose a teardrop hem for that, and let's choose to press apply. Maybe we'll have another hem on this one here. Maybe we're going to flip that around, and this time we'll choose a double rather than a teardrop. Again, it fills out the defaults for you, but you can override them. So Inventor's coming in and it's giving you some real nice workflows and functionality, quick and easy. The great benefit of this is it's folded, but there is a need with sheet metal to maybe do things over a bend or detail something when the thing is flat, right? So we have a load of different options for that. Firstly, we do have a create flat pattern button on the far right hand side. You typically don't want to be editing this when it's in flat pattern mode. The reason being is the flat pattern is designed to be just that. It's the flat pattern of the model. If you're wanting to add some detail of it when it's in flat and then refold it, you need to use some of the other functionality that's inside of the sheet metal toolset in order to do that. Otherwise, you will only ever see those features when it's flat, which, okay, it's useful if that's what you want, but most people will want to see that certainly on their 3D model for visualization perspective. So whilst I've got this flat pattern, I'm going to go back to my folded part, and I'm actually going to say that I want to unfold this component. I choose a stationary reference, such as my very first face. I choose one or more bends, I'm going to say all of them, and I press OK. This will naturally give me an error, which is a little bit interesting. Again, I told you I'm no good at this. Bend, relief geometry, replacement of tear failed. Okay, that's fine. I'm just going to ignore that. That will resolve itself when I fold it back up. But that's where I had the relief geometry of a tear. It wasn't particularly happy with that, with the way that I've modeled some of this stuff. So ignoring that for a minute, once I've used the unfold function, I can then put a feature on and then refold the part. So for instance, if I come to this edge here, let's create a sketch on this face and let's go ahead and just draw a slotted cut. So let's go to my rectangle tool, choose a center to center slot, and let's just do I'll tell you what, let's do it fairly accurately. Let's project the geometry and let's snap off the center and go over here and just draw a simple slot. I'm just going to say finish, and I'm going to say that I want to cut that material away. Now that kind of edit, I could have done that when the component was in its folded state, but let's say I want to cut over the bend, because that's going to give you a very different result depending on whether you do that in 3D versus if you do it in 2D. So I'm going to start a sketch again on the face here, and this time I'm going to do the same slot, but I'm going to cut it over the bend. Press finish the sketch, use the cut functionality to cut the thickness away, and then choose refold, the same stationary reference, all of the bends, and press OK. Inventor will go away and refold that metal with that cut over the bend. If I'd have actually done that with something logical rather than a straight line going over the bend, why I did that is anyone's guess but my own. Let's just model it so that the bendy bit is over there, and maybe we'll put a circle over there as well. There we go, and accept that, cut both of those profiles out. There we go. accept again, refold that, all the bends, okay. What you'll find is you get a very expected result with regards to that cut. If I'd have done the same thing in 3D, I'd have had to create a work plane, looking at that, then create a circular cut all the way through, and you wouldn't have got the same shape because it will be treating it like you're cutting it when it's folded. And again, there's workflows to support both that, do it when it's folded, or punched when it's flat or cut when it's flat. Do it in an unfolded state. Again, as you'd expect, your flat pattern will update to show you those components as necessary. Let's just undo a few times and show you some of the other tools, just to give you a fuller appreciation of the kind of stuff that we can do inside of Inventor. So I'm using this drop down for undo, which is great because it allows me to go to the point where I want to with undos rather than mashing Control Z loads of times. This will store X amount of undos depending on your swap file space and stuff like that. I've just been able to undo several iterations of stuff with 2 clicks. So, you know, some real nice shortcut information there. So let's just show you, a couple. So we'll do contour flange and maybe contour roll. So let's start a sketch, look at this now from the front, and let's place on here 2 lines or 3 lines. So let's go from left to the center, up in a flange, up in a flange, and out in a flange. Why couldn't they call it bend? Anyway, up in a flange, and off to the right in a flange. From there, let's finish the sketch and let's choose contour flange. That will allow me to pick a contour. Note that I drew this with hard edges, and Inventor will go in and create flanges on that geometry. Okay, so we've got bends rather than our sharps. Wherever we had a transition, I can come in and choose the length of that, much like using the standard flange tool. Let's go to 50, and there we have our component with a contour flange. If I undo again, a contour roll does a very similar thing, but it works with like a rolling machine. So rather than bending it, it's going to roll it around an axis. So if I create a line, maybe we'll put a center line in here like this, and then maybe from the side we'll just use a line, and then we're going to say from there to there to there and inwards. Finish the sketch, choose a contour roll, grab the component, it picks up the center line because I sketched it. You could change that if you wanted to, and it will pull that around as if you're putting this through a rolling machine. Again, it's quick, it's easy, and it gives you the same functionality. So with both that and the contour flange, I can come in and say that I want to unfold it. I can still select a stationary reference. Stationary reference. Where have you gone? Stationary reference. There we go. All rolls apply, and you have, you know, the non-roll, and then you can do it again to get the flat, so on and so forth. So you've really got some nice functionality here to do what it is that you want to do. So let's just, to finish this off, model up a quick bracket, for example, put it on a drawing and just finish this workflow end to end off. Yes, we've got a load of other functionality in here that we just don't have time to show you it all today, but hopefully this gets you off the mark and gets you started using some sheet metal components. So let's create a sketch on the top plane here. Let's spin this around. Let's use our, let's go for a 2-point, we'll use 2-point center. Let's go for a 2-point center rectangle, and let's say that we want to have a small bracket for hanging a shelf up or connecting 2 components together. So we want something that's fairly small. So let's scroll in here and say 150 millimeters by 75. Perfect. So there's my base piece of metal. Finish the sketch. Let's create a face. Press OK. Let's then grab our flange tool, select the top face here, bend that round by 90 degrees, and again we've got a distance here. Let's match what we had here as 125 and press OK. From there, let's go ahead and maybe just create another couple of flanges just so that we've got a few more bends. Let's go with this one. Let's select that and say that we want to have offset, again like we had earlier. So let's have it offset from this face. We're going to have that offset by 25 millimeters. And then the second offset, let's have it from this point, and let's have it as 0. Perfect. Press OK. I'm then going to create a cut along there. So let's create a sketch on that face. Let's project the geometry of the face. Create a rough cut here, as long as it's tangent and tangent, I don't really care. So let's say tangent there to there. Fantastic. Finish the sketch and cut this material. No. Try that again. Why did I not have a closed loop there? Is anyone's guess? You are closed. And are you closed? You should be closed. Yes. Projected, projected. Okay, second time's a charm. Cut. Right click, select other. Good old Inventor. I want that one. Perfect. Let's cut that away. Great. That flange is massive. We don't want it that big. Let's go down to 50 mil for that one. I'm going to have to edit that sketch, which is a bit annoying. I wish I'd have seen that first time round, but never mind. As I keep saying, these sessions that air every Thursday are very much unpracticed, uncut, warts and all, and just me basically going on about stuff for the length of however long I go along about stuff for. So you'll have to excuse me, but hopefully it gives you a warts and all indication of how we're doing. There we go. Finish the sketch, and there's the cut. Great. So we've got our component. Let's just add a couple of holes on there. I'm going to be really lazy and just do this. Don't think badly of me. 3 holes there, and let's do 3 holes here. I don't mind about the sizes or the placements. I'm going to cut these 1, 2, 3. Okay. And cut these 1, 2, 3. Okay. What we have is a really nice sheet metal bracket. We're going to change the material and say that this is some stainless steel. There we go, stainless steel, great. I'm going to create a flat pattern, and I'm going to save this component as part 1. No, I'm not. I'm going to save it as sheet metal, and I'm going to put that in my workspace under a new folder called sheet metal, and I'm going to save. Now from here I have a 3D model and a flat pattern. So I can say that I want to create a new drawing view using my standard DWG. I don't need a special DWG file for my sheet metal components, so use a standard DWG, and then with that DWG I can do 2 things. Firstly, I want to place a view of my flat pattern. I want that flat pattern to be viewed from the profile, so in this case from the back. I'm just going to do it that way so it fits a little bit nicer on my sheet. I don't think I'll fit a 1-to-1 on there. Oh, just about, that'll do. I will do 1-to-2 just so I've got the room for some dimensions. I won't put some crazy scale on there, so let's go 1-to-2 and place that down like so. Alongside there, I also want to have a base view of my folded model for reference of the thing when it's folded. And I can place that up there, have it shaded, press OK. Against this, I can then use it like a standard drawing. I can retrieve dimensions from the sketches or from model-based definitions. I can place my dimensions, so on and so forth, manually, as you would absolutely expect. But I can also pull on those sheet metal functions. So I can come in and say that I want to put bend lines in there and start adding information about the bends for each one of those bends. If I've got loads of stuff going on, I can then start adding bend tables by saying that I want to add a general table, selecting a view that's relating to a flat pattern, choosing the columns that I'm after, hitting OK, and then placing it down on my sheet. Really badly on my sheet, looks like my title block is ever so badly put together. But there we go. I've only got 2 bends, but you get the idea. We've really got some fast workflows, and these bends, although I've placed bend notes in the way, are then identified on there. Go and just tidy the template a little bit so that those go either above or below the lines, and this starts to give you a really, really nice output. Other things that you can do with that sheet metal, we can use sheet metal with multibody solids for the past, 3 years or so now in Inventor, if not a little bit longer. So if any of you are used to modeling in context and then turning that context into an assembly, because you've said new solid, that functionality is also supported within the sheet metal workflows. So you can model something like a sheet metal box or a sheet metal case or something that has a lot of relationships to one another in context as a single lump, and then split those components out into individual entities. So that's really useful if you're doing that, or maybe making something like a lobster back or a connection piece that's got a lot of use to modeling it together, but then having to split it out, ripping the components and having flats of all of them. So there's a lot of stuff in there, and actually it works really well. It's easy to use. If you're used to Inventor, you should pick it up no end. And actually anyone with Fusion, the same functionality really exists inside of Fusion, so you can do the same thing. Once you've got that, if you're using Inventor or Fusion to put it through CAM to get a plasma cut to go around the outside, for example, and start cutting this out and then getting it bent, is really straightforward. So hopefully that's been useful today, and that's given you an understanding or an appreciation on how this functionality works inside of Fusion Inventor, and something that you can go on and use moving forward. As I say, it's been a pleasure to have you here. We will be back on, I think, next week on Thursday again at 2 p.m. Unless anything changes. Follow us on social media, so on and so forth, to find out what that session is going to be on. Any questions or feedback, get in touch, let us know, give us a like, give us a subscribe. Thank you for having us, and we'll see you again soon. Take care. Thank you very much. Goodbye. I say goodbye. I can't remember where I put the button to turn the screen off. Goodbye.